Hello and welcome to this week's What Were They Thinking? Children's kidneys. Among the news items we have for you this week is a virus that is affecting children's livers in the US. The positive upside, beyond gratitude and saving someone's life, of blood donations. Weird microbes that turn methane into electricity. The investigation of how we domesticated corn, and the creation of an engine that doesn't require combustion. The timestamps for these and other news items can be found in the description box below. Let's start with liver disease and a virus. As should be quite apparent from the last few years, viruses are a nasty thing. Other than the fact that they can cause diseases in their own right, can affect the liver. Others can have impact on the reproductive system. There are many complications that arise from it, and in this case, there is one that the CDC is on particular alert about, as it is compromising liver function. The liver, of course, is, to be quite blunt about it, effectively an essential organ. You really can't do without it. It can take a lot of damage, and it can be abused, but eventually it will stop working. And when that happens, you will die. Getting to that point is a long process, and this is where liver disease exists. It is where the liver is damaged, and the tissue is replaced with scar tissue, a process called cirrhosis. If the liver disease does not cause death in the near future, it can cause long-term impaired function. And this is where 9 cases of pediatric hepatitis have been reported. Hepatitis is one of the diseases for which most children in developed countries will receive a range of vaccines. These are intended to prevent infection with viruses and the complications that we've mentioned. The CDC noted these particular cases because they were present in children, and it's unusual. So far, through good fortune, none of the children involved have died. However, 3 of them do have liver failure, and 2 of them have had to have liver transplants. That's how serious something like this can be. In this case, the hepatitis or inflammation of the liver is being caused by an adenovirus, and at least this is fortunately not another example of COVID complications. The issue is, it's a large number of children that have had these infections causing these injuries and, as a consequence, the complications. All the children are young, between 1 and 6 years old. All of that is the downside, but it's not the worst news. The virus in question is called Adenovirus 41, and this virus spreads through respiratory exposure, just like COVID-19. Because of this, you can begin to understand why it's a problem. Sadly, respiratory systems aren't the only way to be able to be infected. It can also spread through feces and by not washing your hands properly. Since this is a case that involves children who are otherwise healthy and not immunocompromised, to have so many in a cluster, and for them not to otherwise be vulnerable to infection, is a concern. There's also no treatment in this case. Unlike COVID, we're not anticipating there being some last-minute rush for a vaccine. Going from the disappointing news about children who are infected with the virus to another upside to blood donations. As a general rule, if you donate blood, it can be used a number of ways. The whole blood product can be given to people who have had acute blood loss or need transfusions in other circumstances. It can be further processed and have the blood cells separated from the plasma. You may even be asked to donate plasma alone. These can then be used to create even more products again. At least as far as theory goes, every blood donation can be used to save the lives of up to 3, if not 4 other people. That by itself is, in most countries, a good enough reason to donate. In some countries, there is further reward, whether that is in the form of sweets and drinks after the fact, or a cash reward. In some countries, there's no reward at all, and it's a purely philanthropic gesture. That's where this research becomes important. The idea that there may be a benefit to you in donating blood that is directly related to the donation and unrelated to any reward you might receive. The research found that by donating blood, there was a significant and permanent reduction in chemicals that were considered permanently found in the body once you were exposed. These are perfluoroalkyl and perfluoroalkyl substances. The problem with these substances is that they don't tend to break down in nature or the body. This means if you're in an occupation where you have a high risk of exposure, you're likely to acquire an ever-increasing amount. That's where the firefighters involved in this were able to look at it. Just under 300 firefighters from Australia had their blood tested and examined over a period of 12 months. Because of what they use in their job, they're exposed to the chemical in question, and they should have higher levels in their blood. Those who donated blood or plasma had a reduction in the amount present. This means that there is an unexpected benefit to chemicals that might be seen as undesirable, especially in occupations like firefighting. The researchers explain that it's likely the chemicals that they were looking at in particular preferentially bind to proteins in blood, and so when you're taking them out of blood in the form of a donation, you reduce the amount permanently. This means the donation benefits not only society, but the firefighters in this study, or at least according to the researchers. Working our way down the food chain, there's been a study looking at what drives insect die-off. As a general rule, many agricultural areas don't want insects. They tend to eat the harvestable foods and they reduce yield. This is obviously a problem. This has led to all manner of complaints about the use of pesticides. While there is research to indicate both benefits and detriments to the use, it's often been somewhat difficult to reach a definitive conclusion based on the whole of the evidence. This can be down to different quality studies, lack of sample size, duration, and so on. This is where the study in question begins to help somewhat. It is much larger than many other studies, with 6,000 different locations across the globe, and 20 years of evidence. They were trying to understand not only how abundant insects were, but the diversity of those insects over 20 years. They primarily found that two factors came into play: agricultural intensity and climate change. Those areas with the most intensive agricultural use and largest change in temperature over the last 20 years had the biggest change in insect diversity and density. This is not necessarily a new finding. It's been mentioned in past research and past videos that the monocultures that we use for most plantations and farming now tend to create complications. A monocrop is just one thing, and it is liable to be affected by something as simple as a virus. Historically, we have learnt from this and then forgotten about it, and then had to relearn the lesson, and then consequently forgotten about it again. Hopefully, with studies like this further explaining the benefits of having a somewhat more diverse field, or at least fields that aren't the same side by side, farmers will begin to alter their practices somewhat. This will then have benefits on the environment. If that's not viable, then maintaining more of the natural habitat, or providing reserves or reservoirs where native and natural wildlife may live, could be the answer. Next we go to an even smaller scale, and looking at microbes. At a very broad level, creating a living battery isn't that weird. We already have something similar with methane generators. These are large tanks in which biological material is put in, degraded, and then methane is produced to be burnt as a natural gas. That is useful for very small scale setups. Think of something like the size of a house that is off-grid. The difficulty is when you try and scale it up. The process of using even a small-sized engine to try and turn the methane into energy needs to be so large that it's impractical. This is one reason why we've consolidated most of our energy resources into power plants. Sadly, those same power plants are involved in producing methane that could be contributing significantly to global warming. Therefore, the ability to take methane, one of those major players, and use it to produce energy that is then able to reduce the amount of greenhouse gas effect is desirable, especially if we can use it as a battery. The Dutch researchers have taken this approach by creating microbes that can take methane, convert it into electricity, and then be able to use it as a power source. This is substantially better than what is otherwise used in the reactions we've mentioned previously. Normally, less than half of the methane produced as a biofuel is able to be turned into power. With microbes, it's substantially more. The way it works is that the small archaea involved are able to use a chain of chemicals to be able to take electrons and take them off of the methane. This is what generates that electricity. By doing that, they're able to then offload it and draw it away, and it creates a power cell. Admittedly, the amount of power is tiny, but then we're talking about microbes, so scale is going to be important. As it is now, the bacteria are able to produce approximately 274 milliamps per centimeter square at the high end. This is a very small amount of power, but it's enough to be able to start working with what you need. Consider that your typical 18650 lithium-ion battery that can be found in many devices, such as laptop batteries, has a surface area approximately in the range of 418 centimeters. When you then start looking at how much you're going to be able to get from this, you get reasonably high numbers in the long term. Chances are that the actual output will vary substantially, and the challenge will be regulating just how much power the battery generates. Taking a step back and looking now at the development of corn as an agricultural product. Corn as we know it now is nothing like the ancient ancestor. Its ancient ancestor was, almost in a manner of speaking, very similar to wheat. It had a very small number of corn ears. It didn't yield very many of these, and the plant itself wasn't as reliable. Because of that, when we started to get into domestication and agriculture as a species, we needed something reliable. And this is where selective breeding led to something closer to the modern corn kernel that you might be familiar with, and the corn ear if you've ever grown it. This is where research from the Iowa State University is trying to find the original species that it came from in Mexico from about 10,000 years ago. They believe that it was something called a tessent plant, and while they would only produce about 12 corn kernels each, they were very resilient and they tended to be able to survive in some of the harshest conditions, something that could be very useful today. The problem is the corn we grow today, because that domestication and selective breeding process doesn't have the same genes that give it resilience and the ability to survive under harsh conditions. If we could find these, and that is a very big if, it might be possible to put them back into the corn plant and have the maximum number of corn kernels, but also a plant that could be put into a field and not have to have as much water, fertilizer, and pesticide used to maintain it. Going now from agriculture to engineering to a degree, it's the creation of a very small engine that relies on heat but no moving parts. It's something called a solid-state thermovoltaic device, and it's, in a manner of speaking, similar to an Peltier device. What it relies on is very high efficiency and high temperatures to convert heat into electricity. By doing this, it's able to move things without having to rely on moving parts, as everything goes through the solid state. In a manner, it's almost like looking at the way we transfer electricity through poles and lines. Unlike, say, fossil fuels, it doesn't need to be moved itself. The energy is moved, while everything else is stationary. Generally speaking, these devices tend to have severe limitations on their efficiency. This is one reason why they're not used conventionally. The current device has now hit a record of about 40% efficiency, and that is considerably better than many solar panels we have at the moment. Unlike the solar panels that rely on sunlight, this relies on heat differences. And by having that heat difference, these can work at up to 2,400 degrees Celsius. This is nearly twice that temperature in Fahrenheit. By doing so, they're able to work in environments that no engine that we currently have available can work at due to the moving parts. The simple reality is the tolerances are too tight for us to be able to make it as humans, and engineers don't have the materials to be able to compensate for our failures. The final news we have for you this week regards the possible identification of liquid water on one of the moons in our solar system. Europa has long been considered the best candidate for life outside of Earth within our solar system. This is because it has an atmosphere, it appeared to have ice, and, with any luck, it would be able to be warm enough to sustain life given some of its geological activity. The challenge was finding liquid water. Liquid water was going to be needed for life to exist, at its most basic level. And that's what researchers think they may have found. That is, life on Europa that isn't tens of kilometers below the surface, but relatively speaking, just below the surface. And that's done by analysing what's been seen on the topography of that moon. It's very similar to what happens in Greenland with the ice sheets. It's created ridges that are similar to what happens when you get pockets of liquid water. The researchers involved think that it could be possible that water is being forced up onto the surface from an otherwise large reservoir underneath, and then trying to find its way back down. This is then going to lead to the ridges in question, and it would indicate that there is not only movement but geographical activity on Europa. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.